So okay, so in this case, you can see that acknowledgement 100, it is sent twice. So okay, but this acknowledgement is received. When this acknowledgement is received, okay, so the timer for this packet will be stopped, and the host A will assume that this packet has been correctly received. Okay, so in this example we explained that if the acknowledgement of a packet is lost and then the packet will be received duplicate, but through acknowledgement, through the sequence number, the host B or the receiver can identify that these packets are duplicate. Okay, now we are going to discuss another example. Suppose host A and host B, they are sending the data. Host A is sending data to host B. Suppose host A has sends packet number 1 with sequence number 92, and it contains 8 bytes of data, and host A also sends another packet, and it contains the data starting with the sequence number 100, and it contains the 20 bytes of data. Okay, so you can see that this host A is sending 2 packets, and the TCP we have single timer, but the timer will be for the oldest packet. So this is the oldest packet, so the timer will be set for this packet. Okay, so the send base is 92 because this is the oldest packet that is sent and not acknowledged yet. Okay, so you can see that the timer is on for the packet with the sequence number 92 and the send base is 92. Okay, because this is the oldest byte that is sent and not its acknowledgement is not received. Okay, now suppose its timeout is set. So the timeout is set for the oldest packet, for only single timer is running. Okay, so the oldest packet is the packet with the sequence number 92, so the timeout or the timer will be set for the first packet with the sequence number 92. Okay, now suppose that these 2 bytes they are received correctly. First packet is received correctly by host B, so host B sends acknowledgement number 100. Why? Because the first packet it contains the bytes starting with the sequence number 92 up to 99, because it contains 8 bytes. So the acknowledgement is sent for the next byte, next expected byte. So in this case, the up to 99 sequence number, the bytes are received. From 92 to 99 sequence number, these bytes are received correctly. The next one is expecting sequence number 100, so acknowledgement number 100 will be sent for the first packet, and for the second packet it is received the bytes with the sequence number 100 up to 119. So the next expected sequence number will be 1 to 20, so the acknowledgement 120 will be sent for the second packet. Okay, suppose these acknowledgement they are delayed, they get delay, they are delayed. So if they are delayed and its time out is expired, so you can see that in go back in, when the time out is happened for a packet, in go back in, then this packet and subsequent packet they are retransmitted. But in the select to repeat, if the time out for a packet is happened, only that packet is transmitted. In the TCP, it has the best feature of select to repeat. So the best feature of select to repeat is that when the time out happens, so the time out is happened for this packet because the timer is running for the packet with the sequence number 92. So if this time out is expired, only this packet is retransmitted. The other packet that are subsequently retransmitted, they will not be retransmitted. Okay, so this is the best feature of select to repeat, and this is the best feature accommodated of the select to repeat in the TCP as well. Okay, so the timeout happens, so only this packet with the sequence number 92 is retransmitted, because in the TCP when the timeout is happened, so only that packet is retransmitted, so only this packet is retransmitted. Okay, so when this packet is retransmitted, then acknowledgement 100 is received. So when this packet is retransmitted, again its timeout will be set. The timeout will be set for this packet because this is the oldest packet. Why? This is the oldest packet with the sequence number 92. So okay, so again the timer will be set. So when this acknowledgement is received, then the timer will be stopped. The timer will be stopped. Okay, and now the timer will be set for this packet because this becomes the oldest packet that is sent and not acknowledged. Okay, so you can see that when this packet is retransmitted, its timeout is set for this packet. Okay, so when this packet is when acknowledgement number 100 is received, then its timeout will be stopped. Its timeout will be stopped. It means that it is correctly received. Although this acknowledgement is not for this packet, it is for the first time when the packet with the sequence number 92 was sent. Okay, so the sender doesn't know that whether this is the acknowledgement for this latest version or for the oldest version of the packet with sequence number 92. Okay, so in any case the timeout will be stopped. And now the time will be, now we can see that this packet is sent and its timeout and its acknowledgement is not received. So the packet with the sequence number 100, it becomes the oldest one. So the timeout will be set for this packet. Okay, so you can see that the timeout is set for this packet with sequence number 100. Okay, now when the acknowledgement 120 is received, okay, so acknowledgement 120 means that the packet is received, this packet is also received because it contains the data from 100 to 119 bytes. So it means that this is also received. So when it is also received, so its timeout will be also stopped. So its timeout will be stopped. Okay, now you can see that its timeout is expired. Now you can see that this packet is received. When this packet is received, it is received correctly. So through sequence number, it's 92. So through sequence number, this has to be, it will detect that this packet is duplicate. Why? Because it is received already. It is already received. So this duplicate packet will be discarded. By discarding, we means that the host B will not return this packet to the application. It will be discarded. However, the acknowledgement will be sent. As we discussed in this example, that if the packet is received another correctly for the first time, or it is duplicate, or it is received 3 times, each time it is received correctly another, the acknowledgement will be sent. So in this case the acknowledgement will be sent. So you can see the acknowledgement, it arrives twice. So when acknowledgement arrives 20, so through acknowledgement number, the host A can detect that this is the duplicate acknowledgement, so it will be discarded. Okay, it will be discarded. So through this example we have showed that when the timeout value is less than the actual delay, then the premature timeout happens. Okay, so the premature timeout happens, it means that this packet is lost. Okay, so we have discussed the TCP reliable transmission protocol. Okay.